This is just 15 lines of code. In this video, I shall be rewriting it using 10 different paradigms. We shall be rewriting it using object-oriented programming, using functional programming, using event-driven development, and even build our own config parser to develop the same thing using config-driven development. Stay with me and we are going to go to the most complicated of all of them and re-implement the same code using 1500 lines of code. Let's consider that we have a list of tasks. We need to filter to pick only the incompleted ones and then sort them by priority and then output this summary. We already have our first paradigm ready, which is procedural. We simply use what we have been taught and we write the code to output exactly what we want. But now we are going to go with the next one, which is imperative. And imperative is basically telling the computer exactly what to do. In procedural programming, we are trusting the runtime a little. We are trusting that there is this sort there. We are trusting that there is this splice there. For imperative, we are going to be more explicit. Go ahead. I am going to create a new folder, call that imperative. And perfect. We have successfully filtered our task. Now let's continue with our sort. Filter task in our index. It might be slightly more code, but it's a lot more clarified and a lot more self-explanatory. Just by looking at the code, we know exactly what is going on. You don't even need to know about the inner functions of JavaScript. You can simply look at the code, whether that's JavaScript, whether that's Python, whether that's PHP. You're going to know exactly what it means. And well, I'm not going to go into functional programming much because it can take its own tutorial. In fact, it can take a whole series and we would still be taking apart the nitty-gritty of functional programming. But at the very basic, this is simply programming with pure functions, so our code simply takes an input and then output. Take a lot of those pieces together that just takes an input and then output something else and then put them in a pipeline to make a lot more complicated and yet very easily testable and clean code. So I'm going to give you an example. We're done here. We have a very simple code. The script is only 8 lines and it completes the entire problem that we have. However, it's not fully functional yet. I am going to refactor that to be more pure and more functional. We just need to make a few tweaks here and there. So let's begin by defining another function. We are ready to call our generate summary, and all I need to do is console.log. Okay, we're done, and there we go. Our code is fully ready and fully functional. And now we're finally on object-oriented programming. I cannot show the implementation of the remaining code because, well, it's sensitive, and I cannot show confidential properties on YouTube, but you should still be able to guess the context from here. First of all, we import all our classes, followed by initializing a task repository. It's then followed by a filter service and sorting service, which well provides filter and sort service as a parent. And then we have our summary builder, which is going to control the presentation layer and display the entire list of tasks properly. The remaining code is very simple and self-explanatory. We get all tasks, filter them to pick the pending task only, sort them by priority, and then build a summary and then display it. But if you think that oops alone was elegant, you are yet to see oops with design patterns. And as you can see, first of all, we have our repository, we have our factories, and then we have our presentation layer. We begin by configuring the system. We configure our repository, and then we build our strategies, and then we use our strategies and our presentation layer to output the actual result. And if I run that now, it might seem similar, but it's a lot more scalable, and you can easily plug in any strategy or any sorting stat that you can think of. And next we have event driven development, which basically allows us to notify someone when something happens. And using this, we could have asynchronous programming. We can extend our code. So first of all, we import our event bus and the regular task repository. We import all our listeners. We initialize the classes, and then we subscribe all our handlers. We have our pending task listener, which is going to filter our tasks. We have a filtered task listener, which is going to sort our tasks. And then we have our sorted listener, which is going to summarize these tasks. And then we have, let's skip this one. And then we just get a task, we publish a first event, and everything happens automatically. Our code is all there, but it's completely automatic. We don't have to worry about anything at all. And next we have reactive architecture. Let me run that first, and then I'm going to explain the code step by step. There, oh, well, give me a moment. I'm just going to go through it real quick. And there we go. We have our list, and our code is now a lot more scalable. First of all, we have a few core operators. We have all three of our streams. We combine the task and auth stream to get both of their stats at once. We check if we are signed in. Next, we check if we are not signed in, we are simply going to return null. Otherwise, we are going to return our task. Finally, we subscribe to our stream. If we are signed in, we are going to view our summary, and if we are not, we would be able to view a notification to sign in. Well, next up we have config driven development, and this time everything actually happens automatically. Our entire result is here. Let's look at task.yaml. I'm not going to go through the entire code base because, as you might guess, it's slightly too large, but you should be able to guess everything from here. Just look at how secure and how well done our code is. Now next up we have DSL, and DSL is, well, basically it's like SQL but it's called DSL. And look at that. And let me show you the code that makes that possible. Let's look at a rule, and there we go. This is all that we need to do, and everything will be done almost automatically. And finally, we are at the very end with a very own task printer framework. So let me go ahead and run that once more. And as you can see, it prints our task immediately at incredible scale and with unmatched efficiency. It's going to support containerization, it supports parallelization over to several thousands of servers, it supports plugins, hooks, lifecycles, you name it, and our entire business logic is distributed into several layers. So let me know which paradigm you liked, or maybe just go back to procedural or write your code that way. I don't care, but do let me know what you think about all this. Thank you and thanks for watching.